Fluids such as water, air, ethanol, and benzene are Newtonian. This means that a plot of shear stress versus shear rate at a given temperature is a straight line with a constant slope that is independent of the shear rate. We call this slope the viscosity of the fluid. All gases are Newtonian. Also, low molecular weight liquids and solutions of low molecular weight substances in liquids are usually Newtonian. Some examples are aqueous solutions of sugar or salt. Any fluid that does not obey the Newtonian relationship between the shear stress and shear rate is called a non-Newtonian fluid. Alright, so today we'll be making a non-Newtonian fluid out of 2 cups of cornstarch. Add it to the pan. And then slowly mixed with 1 cup of water. This is just Madison tap water, straight from the faucet. Once we get all the water in, we'll be stirring it slowly to get it mixed evenly. And I will use my hand because that is going to be easier.
Begin to show.
Alright, so in this demonstration, I want to show how the viscosity changes within the non-Newtonian fluid as the shear force increases. First of all, I'm going to demonstrate just pure tap water by dropping this fork in. As you can see, it went right to the bottom. Nothing stopped it from going to the bottom. Now I'm going to drop it into the non-Newtonian fluid. As you can see, on impact, the fluid acts as a solid, stopping the fork, but as the force decreases, the fork is now at the bottom, acting like a fluid.
3 different types of fluids are represented on this graph, plotting shear rate on the x-axis versus viscosity on the y-axis. Line A represents a Newtonian fluid such as water. You can notice that the viscosity is constant in respect to the change in shear rate. Line B represents a shear thinning non-Newtonian fluid. A shear thinning fluid is a fluid that has a lower apparent viscosity at higher shear rates, as shown in the graph. A common household example of a shear thinning fluid is hairstyling gel. Line C represents a shear thickening non-Newtonian fluid. A shear thickening fluid has the opposite characteristics as shear thinning fluid. As the shear rate increases, the apparent viscosity increases. The non-Newtonian fluid shown earlier in this video was an example of a shear thickening fluid. The shear rate was high from the impact of the fork, causing the viscosity to increase, making the fluid act more like a solid. After the shear rate had decreased, you can see the fork sink to the bottom, showing the viscosity had decreased from when the fork had impacted the fluid.
Ba 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 ba